Okay, we're here to go over topic 10. This one is on deposition. Again, I highly suggest that you actually read the review book. If I go to question number 1, which evidence best supports the idea that the vast inland sea once covered the Great Plains area of the United States? That would be choice 3. Extensive sedimentary rock layers have been formed there. Because if I'm looking at a sea, I'm building up sediments over time. Number 2. When a river enters the ocean, sediment is deposited. Describe the change in kinetic energy of the river that leads to this event. Remember, kinetic energy is motion. If I'm depositing, that means my kinetic energy is being changed to potential. So my kinetic energy is decreasing. Number 3. A stream is carrying sediment particles ranging from 0.0004 to 25.6 centimeters. When the stream's velocity decreases from 300 to 100 centimeters per second, the stream will most probably deposit. So I'm back to my reference table. I'm going 300 centimeters per second. 100, 200, 300. So as you can see, I'm moving everything. If I go down to 100, alright, I am no longer carrying my boulders, any of my cobbles, or my larger pebbles. But I can carry the medium-sized pebbles, the sand, silt, and clay. So let's go back to the question. The stream will most likely deposit cobbles and pebbles. Boulders would also work, but that's not a choice. Question 4. The rate at which particles are deposited by a stream is least affected by the... Well, we know size matters because the larger particles get deposited first and smaller, smaller, smaller as we go out. The shape also matters because the rounder ones have less buoyancy than the flatter ones, so the rounder ones get deposited first. Velocity has a huge effect, so that's not going to work either. Streams elevation above sea level. Well, that doesn't really matter, but the density of the particles do, because the more dense get deposited before the less dense. So your answer is 3. Number 5. Small spheres that are identical in shape and size are composed of one of the 4 different kinds of substances, A, B, C, and D. Now it's important that they are the same shape and size. The spheres are mixed together and poured into a clear plastic tube filled with water. Which property of the spheres caused them to settle in the tube as shown in the diagram below? Well, they already told you they're identical shape and size, so that means 1 and 2 have to be out. Hardness has no effect. The only other factor that we talked about is density. The most dense is going to get deposited first, and the least dense is going to get deposited last. So D is going to be the most dense, and A would be the least dense. Number 6. The following diagram represents a cross-section of sedimentary deposits. Where would this type of deposition most likely occur? So if I'm looking at it, I have larger ones than smaller ones. Larger ones, smaller ones. Larger and smaller. So I have vertical sorting. Where do I have vertical sorting? Well, that would be in a lake that's fed by a stream that often floods. So early spring, the larger particles. As the temperatures increase, my volume decreases, so my velocity decreases, so it's smaller ones again. Alright, this is the lab that you guys just did with me on lab 20. Number 7. Most of the sediment that covers New York State was deposited by glaciers. Describe a depositional characteristic that these sediments should have in common. Well, remember, we talked about with glaciers. They're unsorted, unlayered. They're till. It's random. Everything and anything that the glacier picked up, it incorporates, and then when it recedes or melts back, it just dumps all that material together. Base your answers to questions 8 and 9 on the following diagram. The diagram shows points A, B, C, and D on a meandering stream. Number 8. Which material is most likely to be transported in suspension? Remember, suspension means it's floating in the water. during periods of slower stream velocity. Well, if it's slower, we know that the smaller the particle requires less velocity. So the slowest stream is going to go is this with the smallest particle, which is clay, which I would use my reference table page 6. Number 9. At which points is the amount of deposition more than the amount of erosion? Well, I'm depositing more on the inside of a meander, and I'm eroding more on the outside. So if I'm depositing, I need to look for the inner part of the meander, and that would be choice D. You can actually see how the sediments have been deposited. They're building up. Where the outside is eroding. Your bank is getting steeper. Number 10. More deposition than erosion will take place in a stream bed when the velocity of the stream decreases. It's slowing down. It doesn't have the carrying capacity any longer. It doesn't have the energy. It's going to deposit it. Number 11. Which is the most probable description of the energy of a particle in an erosional depositional system? Number 1. Particles gain kinetic energy during erosion. Remember, kinetic is motion. I'm moving sediments. I'm eroding. And they lose kinetic energy during deposition. I've slowed down. I don't have the energy. That kinetic energy is going into potential. So 11 is number 1. Base your answers to questions 12 through 14 on the diagram below. The diagram represents the landscape features associated with a meandering stream. An arrow shows the direction of the stream is flowing. Number 12. At which location is stream erosion the greatest? So if I'm looking for it, again, I'm looking for the outer part of a meander, correct? So with that one is going to be location X. Now, I want to make a little comment over here. See the lake over here? Remember we talked about oxbow lakes? That's when the meanders got extremely wide and they came together and they cut each other off. So that's what an oxbow lake would look like. Number 13. The lake most likely formed when a stream changes path. That's because, remember, you cut it off and you straightened it out. That was, remember, we talked about old age in your life cycle of a stream. Number 14. The greatest width of the floodplain is located at... Now, floodplain is that flat area of land that surrounds the river, so it's adjacent to the river. That's going to be A to B. Question 15. Deltas form where? A delta is going to form at the mouth of a stream, correct? So it's going to form at number 2. Stream velocity is reduced. Base your answers to questions 16 through 19 on the following diagram. The diagram represents a glacier moving out of a mountain valley. Water from the melting glacier is flowing into a lake. Letters A through F identify points within the erosional depositional system. So if I'm looking A and B, they're still in the glacier. C marks how far the glacier actually got. That's our terminal moraine. Deposits of unsorted sediments would probably be found at location, well, that's going to be choice C, because that's our terminal moraine. It marks how far the glacier actually made it before it recedes backwards. So it's dumping everything. An interface, remember, we talked about interface means a boundary between two things. An interface between erosion and deposition by the ice is most likely located between points. If I'm coming back to the diagram, here's my ice still at B. I'm depositing at C because that's my moraine, my terminal moraine. So my option is going to be B and C. So I'm eroding at B, depositing at C. 18. The clay-sized sediment particles carried by the water are most probably being deposited at the point. Remember, clay doesn't take a lot of velocity. so I can actually move further into the water. The bigger ones first, and smaller and smaller and smaller. So probably going to be point F. Number 19. Which graph best represents the speed of a sediment particle as it moves from point D to point F? So if I go back to my picture, I'm at D, going to F, I'm getting further into the water, so that means I'm slowing down even more. So my option is going to be, I'm slowing down even more as I go from D to F, choice 1. Base your answers to question 20 through 25 on the following diagrams. Diagram 1 shows melting ice lobes of a continental glacier during the Pleistocene epoch. Diagram 2 represents the landscape features of the same region at present, after the retreat of the continental ice sheet. Letters A through G indicate surface features in this region. Number 20. Which features in diagram 2 are composed of sediments directly deposited by glacial ice? So I'm looking for something that's made with till. Okay, if I'm going with that one, my C is my terminal moraine, and A is going to represent my drumlins. So remember, we talked about drumlins or till, unsorted, unlayered. So is your terminal moraine. 21. Kettle lakes are located nearest to, if I go back to my diagram, if I'm looking at before, my ice blocks, when the ice comes off and sits in that loose sediment, remember we talked about it's like you standing in wet sand. It's going to put a little bit of pressure there. It's going to sink. Over time it's going to melt. So that's going to be choice G. 22. Drumlins that are formed under a lobe of ice are located at, well, we just talked about this one, the letter A. 23. An outwash plain of sorted layered sediments is located at, remember we talked about the outwash plain is the only part of glacier feature that is sorted and layered because it's coming from the stream that's flowing underneath the glacier. So that water goes through the terminal moraine and goes beyond. So that's going to be choice D. 24. A moraine deposit formed at the former interface of glacier and no glacier is located at location, well, we're back to my terminal moraine, letter C. Number 25. Which arrow best represents the direction of movement that formed the deposits shown in diagram 2? So if I go back to diagram 2, remember here's my drumlin. It's showing direction. I know it's got to be in this way. Here's my terminal moraine. Here's my glacier. So my glacier came from the northwest going southeast. Make sure you make a note that they're actually going to give you a direction arrow. North in some of these questions are not always towards the top. Sometimes north has been to the side. So make sure you're really careful. Remember I said detail, detail, detail. So coming from the northwest, going southeast, answer number 1. Good luck. Make sure you email me if you have any questions. I will be putting up your test, weathering and erosion tests. And yes, that includes all types of erosion. Good luck.